Two continuous random variables which are independent will satisfy a couple of things. First of all, there'll be a rectangular region over which the joint distribution f of xy equals f of x times f of y, although it might be necessary to do a change of coordinates before you can see the rectangular region. Also, the conditional PDFs of one variable given another will just be the PDFs of that variable. So f of y given x is just f of y, and f of x given y is just f of x. So let's do an example. Let x and y be independent random variables where the PDF of x is f of x equals 1/9 x squared for 0 less than x less than 3, and y has PDF f of y equals y plus 1 for 0 less than y less than square root 3 plus 1. What is the probability that the point xy is in 1, 2 cross 0, 1/2? That is, if we were to graph x and y, x would be between, here's 1 and 2, and then y, here's maybe 1, and here's 1/2. And x is between 1 and 2, and y is between 0 and 1/2, so at some point in here. These are the points x, y. Okay. Since x and y are independent, their joint distribution f of xy is f of x, f of y, which is 1/9 x squared times y plus 1 over the intervals on which the PDFs are defined. So x is between 0 and 3, and y is between 0 and square root of 3 minus 1. So the intervals we're looking at here are completely contained inside those intervals. So we want to know the probability xy is in 1/2 to 0, 1/2. And we can write the double integral. The integral from 1 to 2, oops, that should be, these are backwards, that should be dy dx. So x is between 1 and 2, and y is between 0 and 1/2. Let me move my little screen out of the way. But the key thing to keep in mind is since these are independent, we can split it up into just an integral over x from 1 to 2, and an integral from y equals 0 to 1/2, and just multiply them together. So taking the integrals, we get x cubed over 27 for the first integral, and for the second integral, we get y squared over 2 plus y. And when we evaluate them over the respective bounds, we get 8 over 27 minus 1 over 27 times 1/8 plus 1/2, which equals 35 over 216. So for continuous random variables that are independent, you can split the integral up into a product of two integrals, and their joint PDF is just the product of the two PDFs.